Good afternoon, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to explain about HIPERLAN. HIPERLAN is nothing but a high performance radio local area network. Is a wireless network that transmits data quickly within a specific area. It was developed in 1990s to provide reliable connections and high speeds in workplaces. It is a European alternative for the IEEE 802.11 standards. It is defined by the European Telecommunications standards. Then the main features of a HIPERLAN are it supports asynchronous and synchronous traffic. It has a range of 100 meters. It has a frequency range of 5 GHz. It has a bit rate of 23.59. It uses time slots to implement QoS. QoS nothing but a quality of service parameters include latency, jitter, bit error rate and a bandwidth. This is nothing but a ETSI brand systems of HIPERLAN access. So it mainly consists of various layers. The first one is a physical layer. The main task in this physical layer is a modulation and a demodulation. The second one is a forward error correction mechanisms. The third is a signal strength measurement and the synchronization between the sender and the receiver. And at last it uses CCA schemes to sense whether the channel is ideal or busy. The next one is a MAC sublayer. It is responsible for processing the packets from the higher layers and also responsible for forwarding mechanisms, power conservation schemes, communication confidently through encryption and decryption methods. Next one is a CAC sublayer. It offers a connectionless data service to the MAC sublayer. The MAC layer uses this service to specify a priority called a channel access mechanism priority to each packet. The PDU with the highest CAM priority and the least residual time will be selected for this access to the channel. The channel access mechanism used is elimination yield non-preemptive access mechanism. It is dynamic, listen and then talk protocol. So the four distinct phases of HIPERLAN are prioritization, elimination, yield and data transmission. So the four distinct phases in the first one, prioritization, whereas it uses 5 distinct priorities from 0 to 4 with 0 being the highest priority. The cycle begins with each station sensing the channel for as many slots as the priority of the packet. So all the stations that successfully sense the channel as ideal for the whole interval proceed to the next phase is the elimination. So during the elimination phase, each station transmits an energy burst of random length. So then during the yield phase, the stations that survived the two previous ones back off for a random number of slots. During the yield phase, the stations that survived the two previous one back off from a random of slots. The station that backs off the shortest interval eventually accesses the channel for the data transmission. All other stations sense the beginning of the transmission and refrain from the transmitting. So then at the last phase, during the transmission phase, the successful delivery of a data packet is acknowledged with an ACK packet. So HIPERLAN type 2. Next generation of HIPERLAN family proposed by ETSI Braun in 1999 is under development. So the main goal of this is providing high-speed communication access to different broadband core networks and moving terminals. The main features of this is it is a connection oriented QoS guaranteed security mechanism handoff. So the process of transferring an empty from one channel to the access point to the another. So the various tasks of the RLC can be summarized as association control function, DLC user connection control, radio resource control, dynamic frequency selection, handoff and a power saving, hyper access and a hyperlink. In parallel to developing the HIPERLAN type 2 standards, it has started work on standards complement to the HIPERLAN type 2. So these are the various relevant organizations and the typical industry backers uses Texas Instruments, Dell Bosch, Ericsson, Nokia, Telia and Zericom. So the main architecture of this HIPERLAN 2 type reference model is shown here. As HIPERLAN 1, it also has a various layers. It is used for the data transmission. The main three control functions are association control function, radio resource control function, DLC user connection control function and These three are the main control functions which is used for various process of authentication, handover, dynamic frequency selection, and power control. So the assessment is a HIPERLAN. What is mean by HIPERLAN and what are the various layers used in HIPERLAN? Mention the control functions. Thank you.